Question 10, a curve has stationary point at 2 comma minus 10 and is such that d square y upon dx squared is equals to 6x. We have to find dy by dx. Now, as the expression for d square y upon dx squared is equals to 6x, to find dy by dx, we'll integrate both the sides. So dy by dx will be is equals to 6x squared upon 2 plus c. Now, to find the value of c, the curve had a stationary point at 2 comma minus 10. So at a stationary point, the dy dx is 0 and the value of x is 2. So this will become 6 into 2 squared upon 2 plus c. Simplifying this, we'll get 6 into 4 upon 2 plus c. We can simplify it to write it as 6 into 2 plus c. So the value of c will be is equals to minus 12. So we can write the expression of dy dx as 6x squared upon 2, which is 3x squared minus 12. In part B, it says find the equation of the curve. So as the dx is equals to 3x squared minus 12, we can first integrate both the sides. So this will become y will be is equals to 3x cubed upon 3 minus 12x plus c. Now to find the value of c, we can substitute the point given in the question, which was 2 and minus 10. So this was a point on the curve. So in place of y, we'll substitute minus 10. So this will become minus 10 is equals to x cubed. So this will become 2 cube minus 12 into 2 plus c. So minus 10 will be is equals to 8 minus 24 plus c, which is equals to minus 10 is equals to minus 16 plus c, or c will be is equals to minus 10 plus 16. So the value of c will be positive 6. Once we have the value of c, we can write the equation of the curve as y is equals to, so y is equals to x cube minus 12x plus 6. In part C, it says find the coordinates of the other stationary point and determine its nature. Now we know that the dy dx is given by the expression 3x squared. So the dy dx was given by the expression 3x squared minus 12. For the stationary point, dy dx is 0. Solving this equation, we'll get 3x squared is equal to positive 12, or x squared will be is equals to 4. Taking the square root of 4, that will become plus minus 2. Now, as we already had x is equals to 2 as one of our points, so the other stationary point or the other coordinate will be x is equals to minus 2. Once we have the value of x as minus 2, to find the y coordinate, we'll substitute this into the equation of the curve. So the equation of the curve was y is equals to x cubed minus 12x plus 6. Substituting x is equals to minus 2, we'll get minus 2 cubed minus 12 into minus 2 plus 6. This will become 8 plus 24 plus 6. Simplifying this, and this will be a minus 8. So minus 8 plus 24 is 16. 16 plus 6 is 22. So the coordinates of the stationary point will become 2 comma 22. And to find the nature of the stationary point, we'll substitute this x value into the double derivative, which was d squared y upon dx squared, which was 6x. So as d squared y upon dx squared was equals to 6x, substituting minus 2, this will give us a negative answer. So as d squared y upon dx squared is less than 0, it means it will be a maximum point. In part B, D, it says find the equation of the tangent to the curve at the point where the curve crosses the y-axis. Now, the equation of the curve is y is equals to x cubed minus 12x plus 6. When it crosses the y-axis, it means that at the y-axis, the x coordinate will be equals to 0. So the y coordinate will become 0 minus 0 plus 6. So we have a point on the 0 comma 6 basically, where the curve crosses the y-axis. And to find the gradient, we know that the expression for dy dx was 3x squared minus 12. Substituting x is equals to 0. So this will become 0 minus 12. The gradient will be is equals to negative 12. Now, once we have the gradient of the tangent, and we have a point, we can find the equation of the tangent by using the formula y minus y1 is equals to m into x minus x1. So the y coordinate is 6. This will become y minus 6 is equals to 12 into x minus 0. Simplifying this, we'll get y is equals to 12x plus, so this was minus 12, so this will become minus 12x plus 6 as the equation of the tangent to the curve where it crosses the y-axis.